All right. All right, so welcome to class 3, week 3. We are starting to get a bit more into the data. Let me see if I can bring up the class website. So part 3, there's yet again another folder for this class up on Dropbox, which if you haven't downloaded, should do that. Not this one. Should look like this. And up on the website there's some slides. They're just brief slides. I'll probably go over them intermittently in class. And then we'll have our project that will open and look at part 3.rmd. But I do want to go through a couple of the muddiest versus clearest points from last time. Just a reminder to fill out your post-class survey. I don't care when you do it. You could do it a couple weeks from now. It doesn't really matter to me, other than if you want your feedback to be discussed and, by the next class. It helps me if you fill that out on the earlier side, but it's not like you have to fill out the survey like right after class or anything. It doesn't matter. I'll just aggregate it all at the end to count for attendance. And that also goes for the fact that if you don't come to class and you want to watch the video and then fill it out, that's perfectly fine as well. So for the pacing was the average is a little bit higher. So I think that means I went a little fast last time, which I understand, and I'll try to slow it down. I know probably those of you who have had like Biostats 511 know some of what we're going to talk about today regarding the tidyverse, but hopefully you learned some new things, and we'll talk a bit about ggplot a bit more today as well, and also a bit more about file organization. And so that was one of the muddiest points from last time, is just our projects in general and file stuff. And I think that's going to be hard for a long time until we just get used to working in our studio. And so hopefully the stuff that we cover today will help clear that up a little bit. Related to that, like what happens when we save our ggplot, where does that go? I'll show you that in real time, but the default is precisely where your RStudio project folder is. So wherever your .rproj file is, that's your RStudio project folder, and that is going to be where things are saved. And so some things that I want to cover in addition to what we did last time is some of those summary functions like visdat. Those are actually that visualization of our data. If you remember, it was a kind of a tile plot, I guess, that had different colors for whether there was missingness or whether something was a character vector versus a numeric vector. And so and that in itself doesn't give you much information beyond what you might see in like skim, for example. But when we talk more about missing data, I'll show some other functions that let you kind of process that visualization to see whether there's missingness patterns. So that can be interesting if you have data where, for instance, a set of variables, let's say 5 variables, often are missing together. That could be because there was some survey that they didn't fill out, or there was a measurement that is related to other measurements, and so all of those measurements were not taken. And so just knowing that about your data can be really important sometimes. And so I'll show examples of that, not this class, but in a future class. And so today we're going to have a little breakout room practice talking about reading in data again. Hopefully, if you've done the homework already, you've had a little more experience with it. One of the questions was how to upload tabs, the separate tabs in Excel files. And so tab is sheet. That's what it's called, sheet in the read Excel function. So just be aware of that. And so you can tell R that you want to read in either the first sheet or the second sheet or any number or the name of it. So for instance, in the TCGA data, I think the first sheet was called BRCA. And so if you say this argument sheet equals BRCA versus sheet equals 1, that's doing the exact same thing. So I tend to use the name of it, just so it's clearer to me to read it like that, and I know what I'm doing. But the number is also an option. And so Today we're going to talk a little bit about how getting help and dealing with errors. And so I'm going to bring this up, this introduction for Read Excel package. And so we'll talk about that. And then there were a couple of people that mentioned the Haven package. I didn't really go over it in class because I wasn't sure how useful it would be to people, but it sounds like there are some people dealing with Stata data. And so not today, but maybe in a couple of weeks, I'll talk a little bit more about Haven. We kind of need to have more coverage of dealing with different types of data in R. So I'm going to work on that, and then maybe we'll have a little bonus section in reading in like Stata data or Stata data from Stata, data output from Stata, or data output from SAS, for example. It's not that much different than reading with Read Excel. It's pretty similar. But there are just a couple extra things, mostly related to labels, that we need to be aware of. And so some specific questions or kind of comments on looking at how we use arguments, like that make clean names, name repair argument that I talked about. And I'll try to keep doing that. I think if you have any questions about any of the arguments, definitely let me know. I know it can be really difficult sometimes just reading the help documentation to see what does it even do. It's oftentimes quite cryptic. So if we can help kind of troubleshoot that, that is a useful thing. And were there any other questions? I just realized I lost my chat, so hopefully no one's talking to me. Nope, doesn't look like it. All right, so let us go to, let's open the our studio first. So here's the Dropbox. I'm working straight from that folder, so anything that I do is going to be saved in there if you want to get it later. And bring this out. So part 3, make this bigger. So here we have part 3, RMD. If you haven't opened this yet, I would suggest that you knit it. Let me hide this. All right, so I would suggest that you knit this. Maybe I'll just do this real quick, just so you have this code run. And so I've mentioned this kind of offhand, but I like to reemphasize it because it's important. When you have packages in R, which, there we go, which are, like I said, kind of mini libraries or sets of functions that hold other data processing or data analysis tools in them. There's many R functions. There are 2 steps to using a package. You first have to install it on your computer, and you only need to do that once unless you want to update it, and there are often updates. And the second thing you need to do is load it, and loading it is something you need to do every time you use R, like interactively, like in your console or within code, and in your RMD. So you always need to have either, for instance, library tidyverse at the top of your document if you're using tidyverse functions, or what I've done is I've used pacman pload tidyverse, which does exactly the same thing, except it forces it to install if you don't have it. So I'm using this as like a teaching thing because I don't want to have to tell you to install a bunch of packages using the install.package code or like through the interactive way. I'm forcing your computer to install it. But when you're doing your homework, you don't have to use this pacman. It does exactly the same thing. It's your preference. Though if you had used library, in this case, you would say something like library fembetter, library skim R, library tidyverse. You have to say library each time. It doesn't take a list of packages. So this pacman or library loads packages. And so, like I was saying earlier, whenever you knit something, it's really starting from a blank slate. It's from a new R environment. There's nothing loaded, no packages loaded. So you need to be sure that you're loading the libraries that hold the functions you need. And R will complain if you haven't done that. It will say, I don't know what this function is, or this doesn't exist or something. So that's one thing to check. And how do you install packages? I am doing it this way, making your computer install them with the pload. But if you want to install packages like kind of, I never do this, but it is possible, kind of interactively. If you go to the packages tab here next to files, there is an install button, and you can search for something like, I guess I could search tidyverse. So you can install something this way if you want. That's one way to install a package from scratch. I'm not going to do that because it's going to take a while. So that's another option. So again, installing and then loading. And so because I'm doing it all together, you don't have to think about it as much, but it's something to be aware of when you do your own RStudio coding. Any questions about packages or anything? I should mention there are other ways to get packages, like if you've heard of Bioconductor. The standard way is like the rcran website. That's where most of the packages are. There's also Bioconductor, which is like rcran, but it's for mainly bioinformatics and omics type packages. And then there's also GitHub, which is where people can upload packages that are more maybe experimental, or sometimes they're on rcran and GitHub. So at some point, I'll probably show you how to install a GitHub package because you might use one. But it's just another place to get packages from. It's kind of the quirk of R, and the nice thing about R is that it's open source, and so really anyone can write their own package and put it up on the internet for other people to use. All right, so today, the first thing I'm going to talk about are more a little bit about errors and warnings and how to get help, because I think just becoming more comfortable with that helps you be a little more confident in coding. And then I do want to talk about some basic tidyverse verbs or functions, which are arrange and select and filter. And then we'll have a little bit more ggplot fun times. So let me make sure. Okay, where did my slides go? So here we go. So for errors, I have this in the RMD. I also have some slides that have the same information. So you have the links no matter where you go. So the idea with R and errors is mainly that they can be very frustrating and like demoralizing, I could say, because what happens is that you think that you've used this function the same way as you did last time, and then all of a sudden it's giving you some cryptic error. And so it can be very frustrating. Everyone, even seriously advanced coders, have the same issue where you get some cryptic error and can't figure it out. It happens to everyone. But once you do figure it out, you feel very confident and happy with yourself again. So there's like this vicious cycle where you're confident and then you get an error, and then it takes a lot of struggle to get back to it. But I do want to say that R has a lot of output. Some of it looks like an error, but is not actually an error. It's maybe a message that is just, for some reason, they're telling you something that is not relevant to you, but it's relevant to what's going on in the background. And then the other type of message is a warning, and it usually says warning on it. And so that's usually telling you that basically that the data or the arguments isn't quite what the function expected, but it's going to try and do what it thought it was going to do anyway. It's just going to carry on. And so usually that's okay. Sometimes like an example of a warning is like, warning, 12 rows were removed because there was missing data from this linear regression model. And that is probably what you wanted to happen. You didn't have a like set way of dealing with the missing data. So you just wanted to use the complete data. And so it's going to tell you that warning, but it's still going to run the regression, and just be careful about what it's doing and know what it's doing and make sure that the output makes sense. Then error, on the other hand, is going to like actually say error, and it will stop whatever it's doing. So that means that the code can't execute at all given what you have given the function. And usually the errors can be quite difficult to understand. They use strange language and syntax and terms that no one really knows unless you're a hardcore coder person. So how do we even deal with them? Usually I would say I Google it. And I think, and these aren't, I'm adapting Ted's slides from last year. His way of dealing with errors is the same way I deal with errors. I think I added like 1 or 2 extra lines here, but same resources, same way of figuring out how things went wrong, which is encouraging. I think Google is our friend. So the first thing I do is Google either the function that I'm using or the error. For example, some kind of cryptic error might be evaluation error, invalid type closure for variable, whatever the variable is. So I'll like Google that in quotes and see if there's any blog post or vignette or our like publication basically that will tell me about it. And that works a surprisingly high number of times, proportion of the times. The one kind of sad thing is that R is just one letter. So when you're Googling R, that doesn't necessarily come up with R code. So sometimes I put R crayon or ggplot or something like that. But I do want to show you one resource. So there are many like online communities and like web question central kind of places. And RStudio has one, RStudio community. So if you have a certain function, like, I don't know, we're going to look up arrange today. So there's going to be many questions about arrange. And just reading through some of these might help you kind of troubleshoot what's gone wrong. It also just is useful to see examples. So if there's a function and then an argument that is confusing or not well described, searching the name of that function and the name of the argument will send you to places that have examples. So kind of a first step is to search things like this. So the RStudio community is a good one. Stack Overflow has been around for years and years and years. And so yeah, 400,000 questions in R. There's a lot. So digging through this can be kind of hard, but usually if you Google the name of the function, you'll get something useful. And I will say for bioinformatics, if you have a certain like genetic or omics question, BioStars is a good one. And I will say that on GitHub, if there's a package like any of the tidyverse packages are probably also on GitHub. And so that's a good place to search for documentation and also function names. So like this example, let's see, this button here takes you to GitHub's advanced search. So let's say there's a function called like glmnet. It's a bioconductor package. And so I searched that function name and it gives me repositories, which isn't that useful. But if you click on the code, it's gonna make me sign in. If you click on the code button, this is what happened when my computer restarted everything. The joys of modern technology, two-factor authentication. If you, I guess you have to have a GitHub account to do this, but if you do, and you click on code, so now it's looking through our code that people have put on GitHub. And what I do is I look down here to try and find examples of people using that function. So here's one. And so I might go into this file and look at their code and see how they used it. I know you need like an X data set and a Y data set and some parameter and things. And so just seeing how other people use code really helps me learn the best way to use it. So there are, just so you know, lots of resources. Here we have a question. When it comes to using the tools for biostats method, is it important for the order in which you use the tools within these packages? I would say it depends on what you're trying to do. It doesn't matter what order. Well, this is actually a kind of a complicated question because it depends on how many packages you're loading. I would say most packages don't overlap in the names of their functions. But then oftentimes you will get packages that use the same name of the function. And so when you load libraries, that is one thing to be a little bit aware of. Maybe one of these classes, I'll show you an example. But the order in which you load the libraries does matter then. But in general, it doesn't matter. And so if you load all your packages at once, put them in whatever order you want, most of the time you and then you can use the functions from any of those packages in the order. Like, it doesn't matter. You just do your analyses in the order that makes sense for like your work, basically. Hopefully that answered your question. Any other questions about that? Okay. So I do want to say, trying to find if I put the link in here. No, well, I'll show you some vignettes in a second, but so Googling and then also just looking at the documentation. And so some packages have better documentation than others. And I'll show you an example of some in a minute. The other thing is if you're having an error, like especially in this class, ask in Slack, because probably someone else has had the same error. And also we all have our blind spots. It can be tough to see misspellings or misplaced parentheses and all that. So just having someone else look at it, the more you look at one thing and it's not going to appear to you. It's going to be harder and harder to see that silly little like missing parentheses or something. So copy it into Slack and paste it there or take a screenshot. I think that is really helpful. Oh, and this is another tip. If you have done something and you get an error, but you notice there are a lot of errors, usually what you need is the one that's at the bottom, because it's like a cascade where if something inside the function is broken, it's going to lead to another part that is then broken. And so you're going to get a bunch of errors and most of them don't matter. It's really just the first one. And then the first one in this case is going to be the last one. So that's not a hard and sturdy rule, but don't get overwhelmed if there are many, many errors. It's just because one thing was broken and then nothing else could work after that. So don't get too worried about that. And so asking for help also, that like Stack Overflow and the RStudio community are good places to ask questions. Actually, one of my coworkers in the biostat group, Emil, I'm going to pick on him and show one of his examples. He asks questions in the RStudio community sometimes. And so he asked one about kind of an unexpected behavior in the Tibble function, Tibble function. And so people answered. And I will say that when you ask a question in any of these communities, you do need to usually provide it's a reproducible example, like minimal reproducible example. So he just made a little tiny data frame and then showed what was happening. Like in order for someone to help you, they have to be able to run it on their own computer too. And so doing that is very useful. Keep that in mind. And there's also another online community here linked if you want to join. Their Slack channel is very, very active and they have a lot of people learning R for data science. That's the book, R for Data Science. And so people go there to ask their questions. It's kind of amazing how many people have joined that. So just keep that in mind. And going back to before we get to here, going back to the RMD, all of this is similar information as what was in the slides. So I'm going to scroll down. And so, yeah, this is what I wanted to show you. I think I have it open. Very good. Nope. Okay, so in terms of documentation, something to know is that some packages have what we call vignettes, and those are going to be kind of mini like help articles with examples and kind of a description of how you use that function. And so for an example, actually we can look at this one first. This is the skim-r vignette. So you can see it describes what the package does and then shows some examples of the skim function. And so you can actually copy and paste all of this and run it in your own computer and it should all load. And so this can be really useful to see, for example, let's see if I can find a good here. Yeah, so most of these are kind of simple because it's skim. So I think usually if there's more complicated like arguments, there might be a good example. So skim t is another function in the skimr package. So they're showing you how to use that, but it just like returns the data frame. So it does basically the same thing. But usually if there are other functions, they talk about how to use them. And most of the tidyverse packages have something like this. The other one I wanted to show was the readxl documentation. This is the readxl.tidyverse.org website. And they have a bunch of articles that deal with kind of strange Excel data issues, like what happens if you have multiple header rows. You can click on that and it gives a vignette about that specific scenario, which actually happens a lot. So for example, this data set has name, species, depth, weight, but then also there's the second row that's telling like the units and a little bit of information about that column. But when you try to read that in R, it's gonna think that's data. And so that's a very common issue to deal with. And so they show you how to do that, which is basically read in the header first by just reading in one row, then skip those first two rows and force the column names to be what you read in the first time. So if you ever have that issue, come back to this article and copy this code basically and try and fit it to your data. It can be really useful. I usually have some strange versions of this where there's the names and then some more information above the names. So it's a little bit easier because I can skip that. But in this case, it's flipped. So we are going to have one little breakout room. Oops. Okay. One, there you go. One breakout room activity. So, oh, I forgot another useful thing. One more useful thing is the cheat sheets. So let me copy that. Sorry, there's too many useful things. Oh, I have them open. So the other thing that these tidyverse packages tend to have are what we call cheat sheets. And so just looking at, for example, the ggplot one, most of these you have to download. It's going to be a PDF, and they show you, basically explain what all the important functions do. And so let's see if we can find geom density in here. Yeah, so this is Mary's function here. And so it shows you some of the basic arguments, what kind of kernel for the density you want to pick, but then it also tells you what mappings you need. So for example, geom density, you actually need X or Y, and then you can pick all these other line types, for example. And so one we've worked with is geom point. Here's geom point. And so in your homework, you have to pick an X and a Y and a color, but you could also have picked a shape or a size of the point. I actually don't know what stroke does. And then alpha is the how dark it is, like the opacity. So this can be really nice as like a visual dictionary, basically, for what the package does. Another one that will be useful for things we do today is this data transformation with Dplyr. We're going to talk about some of these verbs if I ever stop talking about help things. And so if you need like a dictionary to look up things, this can be a nice quick one for reference. All right. So back to coding. So for the challenge in the breakout room, I just wanted to give you another chance to load in data. I made a new data set that's a bit messier than our nice data that we used last time. I do want you to create a new markdown, and I haven't shown you technically how to do that. I'm just giving you markdown. So if you haven't done that yourself, I'm going to show you how to do that right now. There's, as usual, multiple ways to do this. I think common way people do it is the top left is a little plus with a, I guess it's a piece of paper. And so if you click that, and let's say I want to do an R markdown, there's R notebook and R markdown. Those are very similar. I usually just do R markdown, but you could do either. it kind of just has to do with how things are run within the like interactive way. Because I'm just so used to our Markdown, that's what I use. And that's what I've been doing in class. And so it's going to give me an option. Do I want to output to HTML, PDF, or Word? We've been doing HTML. You can give it a title. This is my messy smoking data. And you can, there's other options in here from template. I have a lot of packages loaded, so I might have way more than you do, but these are all different or Markdown templates that are customized in some way. So if fancy, I even created my own in here. But generally you probably just want the vanilla plain R Markdown thing. And so you press OK. And what that's done is opened this new tab with a blank, not blank, a new Markdown and this kind of template of information, which I usually just delete because this is just with like example code and example text. We don't need that. So I'm getting rid of that. The other thing to notice is this isn't saved anywhere yet. You do have to save it before you knit it. So what I'm going to do is you can do Control S or Apple S or however you save things, or press the save button. And so I'm going to call it, what did I tell us to call it? I forgot, Smoke Messy or something. I'm going to call it that. I also forgot to save this as something else in my name, so I'm not overwriting everything. So I'm going to do that too. Save as, it's my version. Okay, so now I have part 3 Minier, and then I have Smoke Messy, and this has nothing in it, but just the simple knitter options thing, which you don't technically need, but I'm leaving this because this means that when I knit it, then echo equals true, which means echo my code. So print out my code. You could set that to equal to false if you didn't want, like, if you wanted to send this to a collaborator, or a clinician, or someone who doesn't care about our code, you could set that equal to false, and it won't show anything. But since we want to see our code, we'll just leave that. And so in the breakout rooms, what I want you to do is kind of talk to each other about any kind of struggles you've had with data loading. I know this can be a hard thing. Some of you are probably more experienced in doing that with homework, but it's a good practice. And so this is going to load data from the same Excel file, not the exact same Excel file, but another Excel file that was used. So just to show you, it's going to open in Excel. Let's see. That's what it looks like. This was the data we worked with last time. We're going to load from this tab. And so you can see I've made it kind of silly. It's just a subset of the previous data. I've added some extra missingness and things. I've made a couple column names not so great and all of that. So I want you to read that in and deal with all the extra junk that I added. And then we'll come back to talk about our experiences, and definitely see, like, double check that you were able to load it in, use glimpse and view just to make sure the numeric columns are actually numeric, like in the homework. Make sure you're reading in the missing data correctly. And then if you finish early and you're just sitting there staring at each other, maybe discuss like what's wrong with this data? Why is it not tidy, or why is it not fulfilling the nice rules that were laid out in that article that was part of the reading, data organization and spreadsheets. That's in class 2 reading, I think, if you need the link. And also if you have any difficulty experiencing loading in our data on your own, I think that would be interesting to hear. And then when you come back, if you want to put any of that information in the chat, we can talk about it all together as well. So it's like 4 o'clock. So we also need a break time. So maybe let's come back at like 4:15. So let me break you out. So feel free to take a break as well. I lost my Zoom controls. There we go. All right, breakout rooms. Any questions before I send you? Oh, there is a question. Is there a way to save an RMD template to the YAML? Yes. The YAML is the way I like it. Yeah, I tend to copy and paste from my old files as well, but there is a way to make a template. It's not trivial. I'll say that you have to make a package and put it in the package. I'll see if I can find some like documentation on how to do that, but it's not as easy as it should be, actually. But copying and pasting is kind of the way I just deal with that anyway. Yeah. Okay, breakout rooms. How many of us are there? 13. So let me do 4. Colin doesn't have to go. I think if you need help too, there's a button that says like ask for help that will ping me. And so let me know if you need help, or you could message on Slack. I'll put Slack up so I can see. So 4:15, although now it's already 4:05. Let's do like 4:17, I guess. I'll send you a message. Let me make sure Colin is not. Okay, so one room is gonna have, oh no, that's okay. All right, opening rooms. See you in a bit.
You respond to the questions in the chat so quickly.
That's good. I just have to look over there and I can see it. So then I see a squirrel and I have to answer it.
Hey, Jessica.
Hey, Liz.
I had surgery on my mouse today.
Oh no.
So I don't really want to, yeah.
Fair. Take a break. Take a long break and rest. That sounds not fun. Okay, that was quick. Sorry, I probably pulled you out in the middle of the sentence, but hopefully you got most of the way there. I'll show you my, oh, here we go. I also realized I think I didn't record the here spiel. So sorry for those of you who aren't in class, but maybe I'll do a little short video on here. Now we should be recording. And so what you should have had here is the here, is just this little function here. Just wrap your function around the name of your data path. And so you can see now my smoke messy is in here. And if I run this, it should work, hopefully, yes. So it's not, once you get used to using it, it's not that hard. It's just kind of wrapping your head around where things live, where your files are, and making sure that's all organized. That can be the hard part. All right, so now let's get to actually like the fun stuff. Hopefully, I'm sure a lot of you have already used these functions in RStudio. I mean, in tidyverse, but we'll have a recap for those of you who have used them. But this is essentially getting into real tidyverse stuff. ggplot kind of counts, but this is real, what I think of as tidyverse. And so we're going to do some data manipulation using kind of the first real data cleaning package that we're using. It's called Dplyr, D-P-L-Y-R. This is kind of your toolbox for filtering, summarizing, transforming your data. There's Dplyr and then there's tidyr. They kind of go hand in hand. I think everything today we'll do is from Dplyr. And so today we'll talk about arrange and filter and select. I don't think we're going to get to these today, but next class we will, in the pipe. So I'll go through all of them together. Together individually. So we're going to use the same data again, but not the messy version, the nicer version on the sheet 1, and just run this chunk. I'll explain what this bit does. I'm just getting rid of some of the columns to make it nicer for printing. And so whenever we use tidyverse code, you'll notice that we often use what we call the pipe. So the pipe is this series of characters, the percent greater than percent. And what that is it's a function, but what it's really intended for is kind of a way to chain together multiple operations, multiple functions, and in a specific order. So let's say we have our data, smoke complete, and I want to, first thing I want to do is load the data, or like pull it, use it in R. I'm working with that data. So that's my first step. Tell R that's the data I want. And then I want to sort it by one column named cigarettes per day. And then after that, I want to filter to only have gender equals males in the data, or male probably. And so those are my 3 steps. The first one's not really a step other than just like an identification. And then the other things are 2 operations that I want to do on the data. And so this pipe function acts like that part and then. So here's how we would do that in code. We'd have our smoke complete, and then we would arrange, which is the function, cigarettes by day, and then we would filter it to only have males, which is filtering for gender equals male. And I'll explain a little bit more about those functions, but think of the pipe, this little part of code, as putting the output of one step as an input of the other. So it's like piping or chaining that together. So if we just look at that first part, smoke complete, and then arrange by cigarettes per day, we could have also have written it like this. Arrange is a function of data and the column name. So I want to arrange my data by cigarettes per day. So if we look at arrange on the help, try to look at the arguments. The first argument is data. And then there's ... That really is giving me room to put the variable names that I want to sort by. And so arrange just means sort, basically. Kind of like in Excel, when you click a column name and you press sort data by that column, it's doing the same thing. So we could either use the pipe or write it like this. But so why would we want to use the pipe? It looks longer here, like it's not really helping anybody. But actually, if we want to do multiple steps, that's where it becomes helpful. So let's say like above, I wanted to arrange and then filter. In order to do that within the function way, the traditional take a function, put a parentheses, put your input in there, you have to do this nested kind of nested function. So we would work from the inside out. We would first filter smoke complete, gender equals male, and then we would arrange by cigarettes per day. This is actually a little backwards, but it's confusing because we have to read what this data is, like what's going on in this step, and then what's happening on the outside. And so all these like nested parentheses, it's hard to tell what argument is going into what function. And you can imagine if you're doing like 12 steps, this could be very, very hard to read. And so the idea is pipes, just line them up one after the other. It takes the smoke complete and puts it, it's like saying the data is here, right? Oops, can't type. It's saying put that smoke complete in that slot. But instead of actually explicitly putting it inside the parentheses, we're using the pipe and then smoke complete, then arrange, then filter. And so one way to do it, like I was saying, is with the pipe. The messy way, the hard to understand way, is to do a bunch of different nested functions. And then another way I see people would probably do, I used to do this a lot, is just do it on each one step at a time, basically. So first I would filter, save that as a new data set, and I would arrange, save that as a new data set. So that is another way to do it without using the pipe. You just have to keep resaving your data over and over and over again in one long pile. So in terms of readability, I would say it's a lot easier to just read this as like a sentence, right? You start out with your data and then you do your data manipulation steps. And so I think that's like the big advantage, is that we are able to build our processing steps or our data cleaning steps line by line. And that can make it a little more clear. So any questions about pipes so far? We could do that help function trick on this if you wanted, and look at the pipe, but yeah, that's what I thought. It's in a lot of different packages. So it basically doesn't give you any information. It says left-hand side, right-hand side, not that useful. So this is not a useful help documentation. But there are many, many, many blog posts and vignettes and whatever talking about how to use the pipe. So I think that's a good supplement to our information. One thing that I should note is that you are not, other than this step, up here, I haven't actually saved my output. So that's one thing I see people get confused about a lot, is what's saved in R. How do I re-invoke it? Like, is this doing the same thing? Like, am I arranging it in my Excel sheet, or am I just arranging it like in R? And so what's really happening is you have this variable smoke complete that is in your environment, which I've minimized so you can't actually see it. I have smoke complete. If I run this, smoke complete has not changed at all. You can see I filtered, well, let's look at it right now. So it has 1152 observations, 1,000 observations. If I ran this, you would imagine it would get smaller because I filtered gender equals male, but it hasn't. And that's because I haven't saved it as smoke complete. Again, I'd have to use the assignment operator or an equal sign and resave it as smoke complete. And I actually wouldn't do that. I would probably call it something else. So let's run that. And so now we have smoke complete male, fewer observations, about half that we had in the original data. And it is now saved in my R environment, but it's not saved anywhere else. Like, it hasn't changed my Excel sheet. That's still the same. It hasn't even been saved outside of R. And so we'll talk about how do we save our data later. That's an important thing and we'll all need to do at some point. So we'll do that. But for now, what I usually do is if I'm doing data manipulation, I'll save it as like smoke cleaned or smoke 2 or something as another name, just to make sure I know which data frame has been cleaned up. Another way to see what you're doing is to type on at the end of this view. So if I run this, we can see my data that I've processed. I guess all I've done here is arrange by cigarettes per day. Oops. So you can see cigarettes per day is in order, smallest to biggest at the bottom. So someone is very 0.008 cigarettes per day. And that's what the view does. It pops it up in that new window, right? So like I was saying, the important part, you haven't saved your work anywhere. You're just manipulating the data in space, kind of. It hasn't done anything with the files or the objects. So like I was saying, arranging doesn't really, arranging just changes the order of my rows, basically like sorting in Excel. And you can do from biggest to smallest as well. That would be descending. I think there's an example down here. If not, then there's descending is this function. So if you wanted to arrange smoke complete by cigarettes per day, but biggest to smallest, I would do that. And then let's say I want to view it. So I can see now we have the largest values at the top, 40, and it's getting smaller. And if we do want to save it as something, you can use the assignment operator or an equal sign and call it something else. I'll run that too, just so you can see. Now we have smoke complete sorted. I could make this bigger, maybe not. Anyway, it's there, it's just cut off. And you can see that it's been saved in my environment. One aside about the pipe, and kind of an annoying thing about tidyverse in general is that ggplot uses the plus sign and everything else uses the pipe. They're not the same, though they do something similar in that they kind of chain operations together, but they're not doing the same thing in that plus isn't like taking data as an argument, really. It's just adding on layers to your ggplot. So you kind of want to keep them separate. You can chain them together, like you can have smoke complete, pipe, ggplot, plus stuff, but it just kind of gets messy. I don't tend to do that, just to keep it a little clear. So I usually save my data as something and then input that into my ggplot code and keep that all tidy, separated. So back to arrange, like I was saying, by default, it ascends or it sorts in ascending order, so from smallest to biggest. But if you want descending order, here's another example. DESC is the descending function. You wrap the name of your column. And I should say, one thing you may notice is there's no quotes around the name of the column. When we're using tidyverse functions and code, we use just the plain name. And so it's kind of nice because usually R tries to fill in my blanks. So let's say if I press tab here, eventually, if I go down a bit, it will show me the names of the variables in that data. So I guess I got rid of my other numeric variables, but we can arrange by, say, tumor stage, and that's arranging by a character vector. And you can't really see, but if we look at it, if I look at the bottom, then we see stage IV was the last one. So that makes sense, alphabetical order. And so you can see I just added the tail function as a pipe as well. A lot of non-tidyverse functions also work. Anything that takes a data frame, you can tack onto like the end of your chaining of your pipes. Is there a way to see variable names in your environment? The way that I know is mostly just to click on this here. They change this a lot. I swear that you used to be able to see them. Like you used to be able to click on it and they would drop down and show you all your variable names, but they got rid of that for some reason. And so I think the only way is to click this little spreadsheet button, which does basically view. It's the same as what we were just doing. I'm not sure why they took that feature away. Once we start dealing with lists and other types of data, you'll see that it looks a little different, but for data frames and Tibble data frames, I think this is our only option, sadly. But I do often use that. This doesn't have a lot of columns, so like let me go back up here. Let's use this example. So the idea is that you can arrange by multiple variables, and so here I'm arranging by descending cigarettes per day and tumor stage next. If I put a comma and press tab, that was where I was scrolling down. It's first of all, it gives me the function arguments, which is fine. Then it gives me the name of the data frames, which are not so useful. Excuse me. And then it gives me the column names here, which can get really useful if I don't remember at all what I called one, like vital status. If I totally forgot the name, I can kind of just scroll around. But it would try and autocorrect for me, or like autofill other column names, which is useful. And so if I run this, we can see, first of all, the first thing it sorts by is cigarettes per day. And then if anything was tied, which happens, so it so happens that the second and third one were tied, then it would sort by tumor stage. But in this case, it's the same tumor stage. So that's actually, it's the same age. This is probably something, I don't know why that's duplicated, but I think probably for this reason, so that we can see the ties. But if it had been something like tied cigarettes per day, and then this was like stage A and stage B, it would have arranged it that way. So multiple variables, just like in Excel, if you do, it gives you that option to like sort by the first column and then by the third column and fifth column, or whatever you're trying to do. It's the same idea. Okay, so arrange sorting, but do note that the arrange order of variables does matter, because this is telling it to sort by tumor stage first and then break any ties by cigarettes per day. So if we had done that, now first it's sorting by tumor stage, the first, because N is earlier in the alphabet than S, it's putting not reported first, and then cigarettes per day here. So actually this is sort of a philosophical debate, but another option when reading in the data is to also add not reported in your NA list, right? Like technically this is missing. So you might actually want your, when you read it in, to be NA equals NA, comma, not reported. So that's something to think about when reading in data. How do you want to see your missingness in a situation like this? Do you want it to be truly missing, or do you actually want that to be a category? Things to think about when reading in data. Okay, so, challenge 3. It's like 5-ish, maybe let's do a 5-minute break and then work on this challenge if you want. This should be fairly simple, just sort by disease. So let's do 5:07 and come back and we'll talk about filtering everything. All right, so let's get back into Tidyverse. I usually like to start with the range just because it is kind of the most simple, I don't know, function or verb or however you think of it, and one we're very familiar with. And the other two that we're often familiar with is this idea of filtering and selecting, which has kind of a funny name, but filtering, to start off, is more of an intuitive word. And it's something we often do, filtering our data based on some values of our data, right? So the example above was like filtering based on the, I think it's called the gender variable. And so in another example is actually to use a numeric vector. So we have our cigarettes per day. What if we wanted to filter only people that had low cigarettes per day values, so less than 20? And so if we run that, you can see here, cigarettes per day, all these values are below, and it's actually sorted, so all these values are below 20. So we read this as smoke complete and then filter cigarettes per day less than 20. And so when we filter on numbers, we can do this kind of math inside the function, and that'll kind of intuitively make sense. But if we want to filter on something like a character vector, this is a situation where I should have changed my font. Let me go to, as a reminder, not added. Nope, I can't even remember how to do this. Tools, global options. Changing my font because it makes this look like one value. There we go. So when we want to filter on a category, we have to say whether or not, let's say, tumor stage equals stage IV. But the key here, and the reason I changed my font, is that you need 2 equal signs. And that is hard to remember sometimes, but you will get an error if you don't do that. So let's run this. And so that's saying filter whenever tumor stage equals stage IV, stage 4. And so we have stage 4 tumors here. And if we scroll down, if we kept looking, that's all stage 4. There's a lot of them, 91 rows. If I had just put equal, let's see what happens. Problem with filter input. And actually, this is one of the few, well, they're trying to be better. Tidyverse does a little bit of better error reporting. It actually suggests that you probably have used equal instead of double equals. Did you mean tumor stage double equals stage 4? Yes, we did. And that's because this is like a logical operator. So we're not saying, we're not setting tumor stage equal to stage 4. We're not just setting an argument, like that's not an argument name. It's a logical operation within R, and double equals is the way we say, is it equal to? So is tumor stage equal to stage 4? And then that's what we're filtering on. So keep that in mind. And even if you want to go further and kind of chain multiple statements together, multiple filtering statements, we have to use a little bit more logic, logical operators. So let's say we have 2 criteria that we want to filter on. We could either filter on both, which is using the AND operator, or we can filter on one or the other. So like the union of those 2 statements. So or and. And uses the ampersand and symbol, or uses this vertical pipe, which is on my keyboard is below my, or above my enter, and it's the shift backslash, at least on a Mac. It's probably the same on a PC. Or you could copy and paste that if you can't find it. So just as an example, let's say I want to filter on gender and tumor stage, and I want people who are defining their gender is male and tumor stage is stage 4. And so the way I would do that is put a little and in between those 2 statements. So here I have gender equals male, tumor stage equals stage 4, smoke complete, and then filter on gender and tumor stage. So let's run that. So now we can see all my genders are male and all my tumor stages are stage 4. This is precisely what we wanted. Though with the filter function, and the way I usually do it is just to use a comma. Though it can be hard to remember, does comma mean and, or does comma mean or? So as long as you remember that comma means and, when you chain multiple filters together, you can just use a comma. So this will do the exact same thing. You can see, same number of rows, 75, 75. But let's say I wanted or, so I wanted male or stage 4. So that means I would take stage 3 or stage 2 if they were gender male. So we can run this, and that has an or sign, which is this pipe. And that will give me, you can see all of this is male or some other stage. And then later, actually, did I already filter on? Oh no, we have some female and stage 4s. So that makes sense. So if you think about it, which of the above 2 code blocks will return a larger number of patients? Well, we can see the answer here because it's 100. It was like 70 something up there, and here it's 800. But so generally the or will return a larger number because it's 2 conditions, but you could have one or the other, and not necessarily both being like the intersection of those 2 sets. So if you click on this, that we did a workshop a while back on data wrangling and have a bunch of examples you can see. This is on a different data set, but you can see some examples like here using is NA. You can filter only on values where BMI is NA, is missing. And so if you want to practice with filter, check out the slide link that's in that document. You can look at and kind of play around with that. Let me see, we can also say equals to a numeric value if we have a numeric. In this case, it was called record. And you can actually do math inside the filter statement. So this is taking a column named BMI divided by weight and whether that ratio is less than 0.5. So it's really powerful in the ways you can use this. We haven't talked about the in function, but that's basically saying grade in this vector. Is it inside that vector? Is it one of these values? Is it 10th or 11th grade? In this one, so there's a lot of different logical operators. This exclamation point is the negation operator. So not is not, negative basically. And so the exclamation point in front of a statement says the opposite of what that is. So this is saying grade is not equal to 9. So I can show you that here. Oops, there we go. So I could say, let's just copy this and just say, do one at a time. So not equal to stage 4. So now if we run this, we get all the data that's everything but stage 4. So that's a very powerful addition to our function. So there's many ways you could filter. Look at those slides for more examples. Look at the filter vignette for examples. It's pretty powerful. And one thing that is helpful for this is to know exactly what values you can even pick. Obviously for like tumor stage, you could kind of scroll down and see, okay, there's stage IA, stage IB, there's a bunch, but like what else is in there? And so if you have a categorical variable like that, and then it's saved as a character or even saved as a factor, which we'll talk about at some point, there are functions that will let us see what values there are. So the first one is being distinct, which takes all of the unique values for that variable, and then you can use a range to get them in order. So here I'm saying smoke complete, and then take all the distinct values of tumor stage, and then arrange by tumor stage. So let's run that. And we can see them in order. Not reported, stage 1. My cat is attacking my chair. Stage IA, stage IB, etc. And it was even cut off. There's 11, so there's one more at the end, stage 4. So something like that is a way to do it. The way I do it is using the janitor package. It's shorter to do it this way. This is one possible way. And actually, let me just run this without arranging. So you can see it shows you all the options, but it's not in order, right? So it's a little less user friendly, I guess, because you have to kind of look for the ones you're looking for, especially if you have a lot of categories. But the other way, the way that I tend to use is the janitor package's function table with a Y. So table, oh, thanks, Colin. I missed one. Do I need to say anything? Did C stand for, yes. C parentheses stands for concatenate. Oh, in that example. Yeah, I'll show another example like that. Okay, so back to table. Smoke complete is then tabling. So we make a table by tumor stage. And that automatically sorts it in order by alphabetic order. It also gives me a count and a percent, which is really nice. So we can see that there are 99 not reported. There's only 7 stage I, stage 1, 91 stage 4. Super useful function. I use table daily probably. And so you can see this just gives us the name, the distinct arrange, whereas this gives us a lot more information. If there had been a missing, let me see, I don't think we had any missingness. Let's see, skim, smoke complete. Do we have any missingness? No. If we had a missingness in one of these character vectors, oh, do I have smoke messy loaded? Let me try that. Here, going back to my smoke messy, I just want to show you what table does when there's missingness. So smoke messy table, tumor, I haven't changed the names yet. Tumor stage. You can see why this is annoying. Having to remember my little bracket things. So here, tumor stage it was that weird variable that was only printed once that we're gonna fix if we have time, hopefully. But there was a lot of missingness by that nature. And so table will also show me NA. And that is nice because I can get an idea of how many missing values we have. 90% missingness in this case. All right. So challenge 4. I want to make sure we get through select and everything. So I'm just going to show you this answer. So we're going to use filter to select patients who have disease equal to LUSC and who smoke less than 1 cigarette per day. So this is exactly what we were just doing. We need to make sure that we filter equals, use the equals sign, not just one equal. And so because we have an and, we can either put the and sign and then the cigarettes per day part, or a comma, which is what I tend to do. And cigarettes per day tries to help me out, less than 1. And so if I run this, we now only have 60 rows. So there's not that as many people. Actually, there's a good amount, less than 1 cigarette per day. But again, remember, I haven't saved this as anything. I'm just printing it out. I'm not saving it as a data frame or anything to use later. So all this work will be lost essentially, unless I save it as another data frame. So keep that in mind. And so I was showing you some things like with the exclamation point and the and sign and the double equals. All those are kind of operators, logical operators and comparison operators, like the less than and the equal sign and the greater than. So this website has a kind of a list of all of them. There's probably one that you need in there. So look, that's a good reference. Any other questions? So for select, that is essentially the kind of the flip of filter, right? So filter was filtering rows. Select, I don't want to say filter, select is subsetting columns. Actually, I didn't show my slides, but there's in the slides for today, we have a little bit of a visual. So subset observations on rows is filter. So you can see this picture. We're taking the blue rows, making a smaller data set by rows, whereas select selects based on columns, so subsetting columns. So we're going to pick, in this case, the second and the third and the fifth column and make a smaller data set. So I find that people have a harder time remembering the word select, which I agree is kind of a weird word, but that is the one we need for columns. So in this case, let's say we only wanted to select or subset the 2 columns named gender and tumor stage. And we run that and we see now it is a tibble of same number of rows as the original one, 1100 or so, and now only 2 columns. So that makes sense. We've only picked out those 2. But the powerful thing with select, besides just being able to list the columns that you want, is there are a lot of like syntax, which is actually called tidy select. And so ways to get columns that you want without explicitly naming them. The simplest one, although you're still naming a column, but in this case, let's say we wanted everything except gender. We just wanted to remove that column. We can use this negative sign in front. So I'll run this. And so negative gender, now we have all the same columns as before, except that one column. And so I could also have done minus age at diagnosis. And now that column is gone. So that is useful. But this is like the most simple way of using select. I'll show you some more complicated examples, but there's a whole long list of examples at this website. For something like this data set actually isn't good for coming up with complicated examples because it's fairly simple. But let's say I wanted to select all columns where the column name contains the word day, which you can imagine, I think in the TCGA data, actually, one of the ones that you had for homework, there were multiple columns that had day or multiple columns that had year. And so if I only want to look at the columns that are like days to birth, days to death, days of follow-up, I would run this. And if I run it here, there's only one column where that condition is satisfied. And so I only have a tibble of one column. But you can imagine in that other data set, I might have 6 columns because they all contain the word day. And so things like this, it's hard to know what options are until you read through like something like this that has all the examples, but it's worth going through. Another one that I use a lot is like ends with. This again, not really that useful in this case. Like, I don't know why you would want to do this here, but you could imagine, let's say you have a bunch of columns that end with time or end with date or something like that. And you're trying to pull out all of that type of information. And so that could be really useful. There's also a starts with, ends with, contains, all of that, many, many options. So let me show you. I thought I had the link. Yeah. In that workshop we did, we had a kind of a similar laundry list of select examples. So you can look that out, look at that when you have time. Not very many. The other link has a lot more examples. So, but not to overwhelm you, I just wanted to show you the shorter list. Let's see, what's another useful one? I mostly showed you those useful ones. Actually, so this is a shorthand to use all columns in order between record and sex. And actually, I think I added that as an example in here somewhere. Didn't? Guess not. Oh, I forgot to finish it. Let me see. So if I'm looking at my data and I see that I want only the last 3 columns, for example, a shorthand way of doing that is going from gender to disease, kind of like the vector like 1 to 3 or 3 to 5, the same idea. It's a consecutive vector from gender to disease, so the last 3 columns. So that's useful, but you have to know the order of your columns and such. I use this a lot if I have a bunch of columns in the beginning that are just kind of not useful information, or if I'm trying to get rid of all the ages and dates and things that are not useful for the data analysis, then I will just use this kind of shorthand, this colon, to go from one column to the other. So there's so many different ways to do different selecting. Another useful one is if you're trying to rearrange your columns, this is a way to do that. If it bothers you that like the record ID is way at the end or somewhere in the middle, often I'll say select and then put the columns I want to be first, and then use this function everything. And so let's see what that does. So what I've done is I've selected tumor stage, then disease, then everything else. So tumor stage, disease, and then all the other columns remain in the same order that they were, but they just move tumor stage and disease into the beginning. So that can make things easier if you're viewing your data or just rearranging it in some way. But again, I haven't saved it as anything. I might save that as smoke complete. And now, if I looked at smoke complete in the view panel, I can see it's been saved as tumor stage, disease, everything else. And also, There's Ted, who taught this class last year, developed a package that has a little interactive workflow, learning about tidy select. I wonder if I could run this so you can see. If you haven't, well, you've probably all knitted this document, so you've probably already run this. Oh no, it's evaluated equal false. So you do need to install the remotes package if you don't have that already, which installs this package from GitHub. This is an example of installing a package that someone created and put on GitHub. But you need to use, instead of install.package, you need to use this special function called install GitHub that's in the remotes package. So it's a little more complicated, but what that does is it installs his package, and then within his tidy owl package, there's this function that pops up. So it popped up on my screen. I can pull it over here. Really helpful, kind of little fun, interactive coding lesson that will let you give some examples on how to use these other kind of helper functions within select. So like all of is another one we haven't covered, or any of. And this is useful because, as you'll see later, this is going to come back. It's not only for select. So it's good to learn some of these now, because later when we do things like mutate, change some of our data, we can use these functions to tell I want to mutate all the columns that start with day, for example. And so that can be a really easy way to do something quickly across all the columns of a certain type. And so knowing these functions now will help with that later. So have fun with that if you have the time. Now this. All right, so just the last description about filter versus select. They're easy to get confused. Filter works on rows, select works on columns. Think of filter in Excel, that one kind of lines up well. Select, we're selecting our relevant variables. So you'll get it straight eventually. And I keep mentioning that we haven't saved our data anywhere. If we look at our environment, we have multiple data sets that I've created. This I think came from the tidy owl thing, so you can ignore that. But the smoke complete, I made a couple sorted and filtered data sets. I have my smoke messy, but none of that is saved on my computer. And so this is the idea of what is real right now. Our data file that we loaded, the smoke complete Excel file, that's real, that's saved on our computer. That hasn't been changed at all. And that's good practice. Don't change your original data set. Don't overwrite your original data set. Keep that intact. We have our code, which I could knit a million times and have the same output every time and work with the data in R, and that's all great. But if we want to save it to our computer, which I'm sure we all want to do eventually, we can create what we might call process data or cleaned data or new data, whatever you want to call it. And that in this case, let's say we want to say smoke complete filter, select all the columns except gender, which is what this negative sign does. Get rid of that column, I don't want that. And then filter smoke cigarettes per day less than 20. And so let's run this line and go back to my environment. I can see process data has shown up. It has 11,000. So I guess there was only one person who had more than 20 cigarettes per day. So it took out one person, took out one column, and now I'm going to write it to my files. And so there are many ways to write data, write CSV or write Excel files. This is going to write it to a CSV file, but there's a function called write Excel CSV, which basically makes a CSV file open in Excel properly. I tend to actually just use write CSV function, but I think it's better practice to use this one if you're planning on opening that CSV file in Excel. And if you don't know what a CSV file is, it's basically just a text file that has comma separated. So every column is separated by a comma. Every row is separated by a new line. And it's a common way to save data just because there's no extra features. There's no colors or fonts or whatever like we have in Excel. It's just a simple text file. It's readable by many different operating systems, and you don't have to have Excel to open it. The other thing we need to know is where are we saving this? I think if I had just said save it, let me show you what happens if I save it as just some file name. So process data.csv, you have to tell it the name of the file. Generally, you need to put the .csv at the end. If I run this line, if I look, now I can see it here, process data CSV. So it put it in my RStudio project folder, which is the part 3 folder. And it's here, and I can even view the file. It's going to open it up. That's what it looks like. Commas everywhere and hard to read, especially if it's a really long, a lot of columns. This can get unwieldy, but usually you open these up in Excel, so that's fine. But if I want to put it in my data file folder, which I already have because I knitted this, we would put data / the name of the file. And to be safe, I put a here around it, just in case I had moved my RMD somewhere. So let's run that. And so we can see in this data folder is process data.csv. It's the same, looks the same, it's the same file. And so that is where it lives. And now that's real. Now that has been your output, and it can be found if I go to show folder, a new window, which opens way over here. You can see it here. I can even, if I try to open this, it's going to open in Excel over here. And there it is. It's our semi-filtered, semi-selected data set. All ready for us to use however we like. All right, so I do think this will be useful. So going back to our messy data and our breakout rooms, I'm not going to explain how to use these functions. I want you to just try them and see how they work. I will say the first 2 are very simple. You just have to pipe them on to your data and see what they do. So like use your view function or use your glimpse function to see what's going on when you do that. And then this fill one, you can try it and see what happens, but you'll probably need to read the documentation or talk to each other about how to use fill. If you can't figure it out, we'll come back and talk about it. So what I want you to do is clean the names, because as we noticed, there's some messy names. Remove those empty rows that we were talking about earlier. There's blank spaces in between the groups and in between the header. Fill in those tumor stage values that I purposefully left empty. Remove the notes column. So subset your data by removing that one column, and then save the data frame as a CSV. So this will be our last breakout room challenge. It looks like we lost some people, so I might well, we'll see what happens if I break you out. We'll try for 10 minutes. Come back early if you finish early, and then we can keep going. If not, we'll see how it goes. Let me refind my okay, looks like everyone still has 2 or 3 people in it, so you won't all be alone. So come back at like 5:47 and we'll talk about that. Looks like Laura might need to be. All right, hopefully you all got part of the way through at least. I don't know if everyone got to fill, but we can go through the answers. Were there any questions that came up that anyone want to ask first? Okay, I think we're all back. So just to remind you, these were the column names of our smoke messy. We had some spaces, we had some parentheses. And so one way I showed you last time was to actually clean them in the read Excel function using that name repair argument. But another simple way to do that is also to use another janitor function, which is clean names. So I'm going to rename that data as smoke messy clean and look at the column names now. And so we can see that the clean names function puts an underscore in between all the spaces, gets rid of all my weird characters. Here I've made a data frame or a tibble of the old names and the new names lined up next to each other, just so you can see. And so tumor stage, you can see turned, and also lowercase everything, puts everything, including like capital D, capital N. So make note of that when you are later using your select functions. It's changed everything to lowercase, and that's just easier to remember just for consistency to have everything lowercase. Tissue underscore organ, age underscore days. So that's how kind of a simple, quick way to clean up all our messy names. And so another thing that we were discussing earlier is that there's all these missing rows. And so one kind of a useful function to just run, even if you don't notice that there are any missing rows, is this remove empty. And so you can actually, you don't need the argument. I think this by default is which equals rows and columns. So let's look at the documentation. Remove empty. So you can see the argument says which one of rows or columns, because what if you only want to remove the empty rows or you only want to remove the empty columns? You would just pick one. So like this, I would get rid of rows if I only wanted that. But I want to remove the empty rows and columns, even though I don't think there are any empty columns, but just to be safe, I'll do that. And then if I look at the head, its first 10 rows now, all those weird empty rows are gone, simply just disappeared. And so that is handy. I use that often. And sometimes there's just weird empty columns that are just annoying and you want to get rid of them. So that's the way to do it. So the tricky one was fill, I think is the next one, right? Yeah. So this tumor stage, you can see that not reported was then there was a bunch of blanks. And that's because whoever entered the data just wrote essentially like group 1 and then group 2 and then didn't bother to fill it in. You can fill it in Excel. That works. That's one way to do it. So we do kind of want to avoid any like original data manipulation in Excel because it's not reproducible, right? We might not remember exactly what we did. So it's a little more reproducible, friendly to do this in R. And the way we use fill is we can use it in the pipe. So we say smoke messy clean and then fill. And we need the first argument to be the name of the column that we're filling. And then we need to tell it the direction, although I think down might be the default direction. So fill, this is an example actually of a function name that is in 2 different packages. The same, actually fill is not really a function in ggplot, so it's not a good example. But this can happen where the same function name is in 2 different packages doing 2 different things. And we'll talk about how to deal with that at some point. But for now, I want this one. Fill is actually in tidy R. But since we loaded the tidyverse, it should be there ready to use. And so here it says direction can be down, up, or up, down, which is hard to think about. Down, up means it would fill down, and then the next one would go down and then up if there was anything left to fill up. But I can't even think of a good scenario where that would be useful. I'm sure there are. Usually down and up are just the ones we're gonna work with. I guess if not reported had some spaces above it and you wanted to fill that up and down as well, that might be one way. But for our purpose, we want down because we want all of this to be in that group. And I kind of tried to denote that with the, do I have it open still? Well, I think I colored the groups in different colors, which was a clue that those should be all the same group, the same tumor stage. So what happens if I run that? So smoke messy clean and then remove empty, wrong one. Smoke messy clean and then fill tumor stage down. So let's look at that head. So now we can see tumor stage is now not reported, down to the part where it was empty, up into stage IA, which now is filled down below. So one function filled in all of that. Obviously, you can put multiple columns, and look how it says tidy select. That's giving me a clue that I could have said something like tumor stage to barcode. And that doesn't mean anything because it's not going to do anything different because there's no blanks in barcode. But if there had been, well, actually, maybe they were. No, I don't think diagnosis or barcode had any missing data. But if they had missing data, it would have filled down from there. And so you do have to be careful because it needs to be in a meaningful order, right? Tumor stage was in a meaningful order. So we wanted it to just blindly fill everything below the not reported and below the stage IA. We probably wouldn't want to do that with diagnosis unless we knew that they were grouped by diagnosis. So something to be careful with. Though when we need it, it is a useful function to use. And the last one, manipulation step was to remove that notes column. So we would say smoke messy clean and then select minus notes. And so if we look at that, we can now, I use glimpse to see that notes, which used to be that last column, was gone. So it's a little bit cleaned up. We have our clean names, we have our filled in tumor stage, just kind of ready to go. And so if I wanted to save this, we could use the right Excel CSV. Though because we're now in this, where are we? Markdown folder. And if we want to put it back in the data folder, we need to use here. So here is going to look relative to the our proj folder in the data. And if I run this, hopefully, data. Why is that not running? That's weird. Am I on the right? This is a example of doing things that you're not expecting it to do. Let's see what this is. Troubleshooting. Mark repos data. Yeah. Oh, I have the wrong file open. Sorry. All this time I was working in my other, I have 2 copies of this file and I was using my other one. So in theory, if you had run this, it would have put it in here, but it's using this other folder, which is not the one I'm in. Sorry, that's confusing. But that's a good example of troubleshooting why that wasn't working. What I did was I ran here data smoke messy clean to figure out where does it think that it's putting it. And it's telling me it's putting in the smoke data into the SPH programming materials, but I want to be in SPH programming class folders. The joys of coming up with materials and putting them in different places, which is very confusing. So if you want to save your data in different folders, you have to use the here function is the main point there. I think that's all I wanted to say about that. Any questions about anything? Let me see. So we got through tidyverse, Dplyr stuff. We didn't get to ggplot. I don't want to like really start ggplot since we're coming. Oh, I don't know. Maybe we should at least start ggplot for a few minutes. We definitely don't want to go through it all. But in terms of Dplyr, there are some references in the reading. I think we have the cheat sheet, and then you can also read the vignettes for Dplyr that will give you some more background on that package. And maybe, I don't want to go the full 6:15 because we're not going to finish, but maybe for the next like 5 or so minutes, we'll just get started with ggplot a little bit, just as a refresher and to see a couple more ways to make plots. And when we talked about ggplot in the beginning, we only really showed geom point. I think I showed a couple different personalizationing, kind of like make it nicer, but we didn't really get into all the different ways we can do that. So I want to get more into that. And one way that we can do that is to change all of our axis titles. Actually, I can't remember if we talked about this last time, but the function we do that is labs. So let's say we want to make a plot with our data, smoke complete. We map our x-axis to age at diagnosis, our y-axis to cigarettes per day, and the color is the disease, and we want to draw a point or a scatter plot. That's basically what we did last time. And then if we want to change our title and our x-axis and our y-axis, we would do that in the labs function. And so X is denoting what we want our x-axis to be, Y is denoting what our y-axis would be. So we can see that. I think we did show this last time, where this is all a little bit nicer looking than just age underscore at diagnosis, right? That would have been by default the column name, which if you want to get a plot published, you probably want to personalize it in some way so it looks more publication ready. And I think I showed you last time, if you want the legend title to be different, you could say color equals, let's say, disease type. And then if we run that, then we can see that it's changed. One thing I don't think we talked about last time is you can actually save a plot as a name. So previously we didn't have this part. We just had ggplot plus all the stuff we added on to our ggplot. But here I'm saving it as an object, as like a ggplot plot object. So I'm calling it r_plot. We have this arrow, the assignment operator, and then all the code for our plot. And so that means we can save it as something and then re-invoke it later. We can also add onto it. So good. I don't want to jump too far ahead, but we're going to talk about this later. So if I want to add an aspect later, we're going to talk about faceting. Maybe not today, but next time. And so if I want to add on another layer, I can use the name that I've saved it plus all the other stuff I want to add. Trying to think of another thing I could add. We'll see in a minute. Themes. So this is another thing we're going to talk about. Theme black and white. So it's going back to that original plot and adding a theme. And I could have kept all of that chained together with the pluses. So powerful thing is to save like your base plot. And then if you want to kind of toy around with it, adding different themes or adding different facets or different levels or whatever, different colors, color schemes, you can do that. You can save it and then just keep adding on your customizations. So that's really useful. And this is another theme. So themes in general are just basically a way to visualize your plot, make it look either cleaner. So without a theme, the kind of default theme is this gray background with the white grid lines, no border around the axis lines, and what else? I guess that's kind of, those are the main things. But if you look in the ggplot documentation and on this website here has a bunch of different themes. There are many themes. There's other packages that create themes, but it's the simplest and easiest way to make your plots look nice. So theme minimal is a very simple one. And it makes it look, I don't know, cleaner. It's a white background and there's no border at all. So again, we add that on using the plus sign. So check out all the different themes because there are a lot of really nice ones. And there's a package GG themes, I think it is. Yeah, theme that has kind of a lot of funny themes. Like what if you wanted it to look like an Excel plot? I don't know why. You could do that. You have to install this GG themes package first. I'll put that in here just in case you don't have that. You would run that to install that package, but you can get, there's like theme, like Economist and other things like that. So if you want to just make it look different, that's a simple way to do it. Excuse me. And so, but theme itself, there are ways to customize the theme, and that involves like changing the positioning of your axis labels. Perhaps you want them to be diagonal or vertical to the axis. If you want them to be like a bold font or different colors, all of that kind of thing goes into the theme. And so you can layer on top of, say, theme BW, theme black and white, you can layer on your customization. So what this is doing is saying our plot plus the black and white theme plus change my axis. So here, if we run that, you can see the axis labels are now 90 degrees, so vertical, up and down. Which can be really useful if you have long categories or vertical name, x-axis name. So something to keep in mind. I use this all the time, but I was just telling someone that I always forget this code and I have to Google it every time. I don't know why. It's like a mental block, but if you Google it, you'll find it. And then the other thing that's useful is to turn off the legend here. If you wanted to get rid of that completely, legend position equals none is a way to do that. So that's a useful thing to know. Sorry, I'm losing my voice here. So I think the last thing I want to cover before we check out is how to save your work. We talked about this last time, but we didn't really look at what was happening. So if we run ggSave, that saves the last plot that was made. So let's look. This is where it saved it in my RStudio project folder. And here. So it made it a JPEG file because I said .jpeg, but I also specified that I wanted the width, excuse me, and the height and the DPI. And so this is actually a high resolution, quite big, 10 inches by 10 inches plot. And so all of that is customizable. And again, you can save it in a different directory, probably using the here function if you are making sure you're putting it in the right image folder. And so if I run this, actually it's already there. If I run this, then awesome plot is now in that folder. And then it looks exactly the same here. So you can save things where you like. You can save them as a ping or PDF or TIFF or whatever you like. So this becomes really useful. Although this saves the most recent plot, I could also have said, what did I call this? Our plot, I think. No, is that what it's called? Our plot. I might need to say plot equals our plot, file name. I think. So what I saw here was it was an error and it was saying device must be null. And that's like completely nonsensical. But I guess that I needed to name my arguments. Sometimes it doesn't know which argument is what. So I told it I want the plot to be our plot and that to be my file name, blah, blah, blah. And so if I look here, I think that's the same as our plot. Double check our plot. Again, awesome plot image. Maybe it's not, this is not working the way I thought it would. Let me see. Oh, I'm in the wrong thing again. I'm so confused. Let me see. I don't know how I ended up with, for some reason, it's my here is not working. So here is actually causing strange issues. Let me go up. I must have opened the wrong file. So let's pretend I was in this folder all along. An image now. Yes, finally. The joys of here. Okay, so I saved not the most recent plot that I made, but the file or the plot named our plot, which was the original one, which didn't have the black and white theme, right? It was the original theme. So that got saved here. So just that's one other benefit of naming our plots is that we can save it later by calling, like invoking that name. And then if you are in the right here, RStudio project, I don't know why it thinks I'm in this other folder, then it should tell you which folder it's looking at, and then it will look in that image folder and put it there. All right, I think we'll stop there. Are there any questions? No? Like, I think, and so depending on, I have to look at the homework again. I might make the homework deadline later because I think we didn't cover all, yeah, we didn't really cover facets or we didn't cover box plots either. So the homework I'll make due after next Wednesday. So don't worry about turning it in by next Wednesday. I'll send everyone a message. Take a little break and you can get started on it if you want. But we haven't totally covered everything, so I don't want to make it due next Wednesday. I'll let you know next week when, well, let's make it, I guess I could make it due in 2 weeks anyway. It doesn't really matter to me. So I'll send everyone that message, and then next week we'll finish up ggplot and talk more about data wrangling. I think we're going to do like mutate and creating variables and moving variables around and such. All right. Well, thanks for coming and staying late, and have a good week. I'll see you next week.
Thank you.
Thanks.
Thank you.